Okay, we are going to go over the homework for lesson 2.3.2, and let's start with the first problem. This problem is a checkpoint for solving linear systems of equation. It will be referred to as checkpoint 2, so sometimes your textbook will talk about this. It says solve each system of equations, so whichever method you have, you can use to solve the problem, all right? So the first one I have here, let's see, I have y equals, I already have y set alone by itself, so I'm going to use substitution to solve for this one. So since y is equal to 3x plus 1, I'm going to plug it into the second equation in place of the y. So you have x plus 3x plus 11 equals 3, and then that will give me a, cleaning this up, I get 4x plus 11 equals 3. Subtract 11, you get 4x equals negative 8, x equals negative 2. Once you have x equals negative 2, now you plug it into the very first equation, and you get y equals 3 times negative 2 plus 11, which is negative 6 plus 11, which gives me 5. So my coordinate is negative 2, 5. Let's check it with the second equation. Negative 2 plus 5 equals 3. Beautiful. So that is my answer. Okay. Part B, we're going to do the same thing. I have y by itself, so I'm going to take the y and plug it into the second y and into the y of the second equation. So you have x minus, don't forget parentheses, 2x plus 3 equals negative 4. Distribute your negative, so minus 2x minus 3 equals negative 4. Combine your like terms, so you get negative x minus 3 equals negative 4. Add 3 to both sides, negative x equals negative 1. And divide both sides by negative, so you get x equals 1. Same thing again. I'm going to plug it into the first equation. So y equals 2 times 1 plus 3. That's 2 plus 3. Y equals 5. So right now my coordinate is 1, 5. Check it with the second equation. 1 minus 5, does that give me negative 4? Yes. So there's my answer. C, I'm sure there's a typo there, but since the equation is incomplete, since there's no equal here, we're just going to eliminate that problem for now. Okay? All right, next problem, I have 2x plus 3y equals 10, 3x minus 4y equals negative 2. So in this case, I would suggest you to use elimination because none of the variables are by itself, and it may be easier to get rid of the one of the variables by multiplying it by a constant. All right, so I'm going to multiply the top by 4, the bottom by 3. That way, the top will give me a 12y, the bottom will give me a negative 12y, and those should cancel out beautifully. So I will have the first equation now becomes 8x plus 12y equals 40. The second equation now becomes 9x minus 12y equals negative 6. We're going to add this up. I get 17x equals 34. Now, and then the y's should go away beautifully, right? So now you have 17x equals 34 divided by 17, x equals 2. Now you have a choice. You can plug this 2 back into any of the equations, the first, the second, or even the new ones. It doesn't matter. Any of those will work. So I'm just going to go ahead and plug in the first one. 2 times 2 plus 3y equals 10. So 2 times 2 is 4 plus 3y equals 10. Subtract the 4, you get 3y equals 6. Y also equals 2. So my coordinate now is 2, 2. Just double check it with the bottom equation. 3 times 2 is 6 minus 4 times 2 is 8. 6 minus 8 is negative 2? Yes. So my answer is correct. All right. Always go back and check your work. It doesn't take you more than a minute to do this, but it will guarantee that you have the right answer. Okay? All right. Hannah-shaped bucket contains an equilateral triangle. Okay, so there's the shape equilateral triangle, an isosceles right triangle, a regular hexagon, a non-isosceles trapezoid, a rhombus, a kite, a parallelogram, and a rectangle. Okay. If she reaches in and selects a shape at random, what is the probability that the shape will meet the criterion described below? So what is the probability that you'll get what is being listed below? First thing I'm going to do, I'm actually going to count how many shapes we have. So 1, 2, 3, 4, 5, 6, 7, 8. So the total is 8. All right. So that would help me figure out the probability so that I don't have to go back and count again how many shapes are there. Okay, so at least 2 sides are congruent. Well, let's see. Equilateral triangle, does that have 2 sides congruent? Yes. Isosceles right triangle, well, isosceles is 2 sides congruent, so that's a second yes. A regular hexagon has 6 sides. All 6 sides are the same, so yes. A non-isosceles trapezoid, so no, because it's non-isosceles, so it doesn't have any congruent sides. A rhombus has 4 sides the same, so yes. A kite has 2 sides the same on top, 2 sides the same on the bottom, so yes. A parallelogram, yes, a parallelogram has 2 pairs of congruent and parallel sides. And a rectangle has 2 pairs of parallel and congruent sides. Okay, so that's 7 out of 8. That is your probability. Okay, again, maybe the books will want it in decimals. It never is very clear to me what they want, so I always give you both answers. So if we take our fraction 7 divided by 8, I will get the decimal 0.875. Okay, all right, moving on. 2 pairs of parallel sides. Okay, so equilateral triangle, no, because 2 pairs of parallel sides imply that you need 4 sides because there's 2 pairs. So first one's a no. Isosceles right triangle, nope. Regular hexagon, well, a hexagon has 6 sides, and because it's regular, they're all the same, and hexagons have parallel sides, 3 pairs of parallel sides. So yes, that's, it says 2 pairs. It doesn't say only 2 pairs. So I have 3 pairs. I think that satisfies the criterion. A non-isosceles trapezoid. So a non-isosceles trapezoid, it has only 1 pair of parallel sides. That's why it's a trapezoid, right? A rhombus has opposite parallel sides, and all sides are congruent. So I do have 2 pairs for a rhombus. A kite has no parallel sides. A parallelogram has 2 pairs of parallel sides again, and a rectangle also has 2 pairs of parallel sides. So that is 4 out of 8, and which is 1/2, and that's 0.5. So 50% chance. Okay, at least 1 pair of parallel sides. Okay, so at least 1 side is parallel. Equilateral, I can't. I have 3 sides. We won't have parallel sides that way. Isosceles right triangle, no parallel sides that way. Regular hexagon has 3 pairs of parallel sides, so that definitely is it. So that's 1 tally. A non-isosceles trapezoid has 1 pair of parallel sides, but that's enough, right? I only need 1 pair. A rhombus, yes. A kite, no. Kite has no parallel sides. A parallelogram, yes. And a rectangle, yes. So my total is 5 out of 8. And that is going to be 0.625. Okay, so that is the probability for part A, B, and C. Moving on, find the area of the trapezoid at the right. What strategies did you use? I'm going to go ahead and go with the formula we have. So the formula says area is 1/2 times base 1 plus base 2 times height. Okay, so let's see what do I have in terms of information. In this picture, I have base 1 this parallel side, so that's 12, beautiful. Base 2 is this bottom side, so that's 18 plus 5, that's 23. Awesome. What about my height? Well, height should be this line. The height must be perpendicular to both of the bases, so both the top and the bottom. So I need that height, but I don't have that length. Well, what can I do? I could take out this triangle right here and just look at this triangle and say, hey, that's a right triangle. Knowing that I have a 5 and a missing side and the hypotenuse of 13, I can use Pythagorean Theorem to help me. So I'm going to call this is height, this is h, right? So off to the side, I'm going to figure that out and go 5 squared plus h squared must equal the hypotenuse squared. Remember, hypotenuse is opposite of the right angle, so that's why 13 is my hypotenuse. I get 25 plus h squared equals 196. Back up, 169. All right, subtract 25, h squared is 144, so h must equal to 12. All right, so now h is 12. Beautiful. Now I have all the pieces and I can figure out my trapezoid area, right? So it's 1/2, base 1 is 12, base 2 is 23, times the height of 12. So it's 1/2 times 35 times 12. My answer is 210. Don't forget your units. 1 tick mark means feet, so square feet. Okay. Next, use the relationship in the diagram below to solve for x if possible. If it is not possible, state how you know. If it is possible, justify your solution by stating which geometric relationship you use. First one, I have a triangle and I see 3 angles. So this is a triangle angle sum. And they all equal to, well, they add up to equal to 180. Okay, so then I take my 3 angles. I have the first angle 3x minus 2, the second angle x plus 8, I have the last angle 2x plus 3, and based on the based on the relationship, I'm going to add them all up and they will equal to 180. Okay? All right, now let's combine like terms. I got 3 x's here, 1 more x and 2 more x. That's 6 x's total. Add the numbers up. So -2 plus 8, that's 6. Plus 3, that's plus 9, equals 180. Subtract 9 on both sides. So you got 6x equals 171 divided by 6. 171 divided by 6, you get 28.5. And if it says, let's double check, solve for x. Okay, so I can box my answer. Always double check. Sometimes the question is not asking you to solve for x, it's asking for the specific angle. Then you got to plug the x back in. Okay? All right. So what is the relationship here? This has a really interesting name. This actually is called alternate exterior angle because this is my parallel lines and this is the outside, and they're on opposite sides of the transversal. So this is called alternate exterior angle, and they are congruent. Alternate exterior angle. And don't forget, they are congruent. All right. Now, if you don't believe me, not a big deal. You can always get the idea that, hey, I can move things up, right? Correspondingly, if I move this up, this becomes 4x plus 18, and you see now they are vertical angles and they're congruent again. So you don't have to use the alternate exterior angle. You could have said, hey, we use corresponding angles and then vertical angles. That would be another way to go about it. Okay. So either way, the two angles are the same. So 6x minus 28 must equal to the other angle of 4x plus 18. Okay. All right, so I'm going to subtract 4x on both sides because I like to have my variables positive. So subtract 4x on both sides. That would give me 2x minus 28 equals 18. Add the 28 over. All right, so that would give me 2x equals 46. X must equal 23. And that is my final answer. Again, I'm only solving for x, so that's it. I don't need to go further than that. Okay. Okay, so in this picture, you have some parallel lines and you have some transversals, but it's not super clear. So let's see if we can get this picture a little bit better, right? So here you have your parallel lines because of the arrows, right? You can kind of extend this so you can see it better. And you actually have a transversal right here. Right here. This is your transversal. Okay. Again, if you need to, tilt your paper a little bit so you can see it better. But what I was trying to show you is that, hey, here's 56 degrees. Correspondingly, this is also 56 degrees. Okay. So why is that good? We don't know. Give me a minute, right? So this is corresponding angles. That's what I use. Then I look at the picture and say, hey, I have this triangle here. I have an isosceles triangle here. And this thing tells me that the two angles down here are the same. So if that side's 56, this is also 56 degrees. All right, so I now use the isosceles triangles idea about it. And then last but not least, I now need to use triangle angle sum because the two 56s and this x here add up to be 180 because they're inside a triangle. So you have x plus 56 plus 56 plus 56 must equal to 180. So that's x plus 112 equals 180. X must equal to 68. And that's it. That's how we solve for x. Okay? All right. Find the maximum and minimum and maximum limits for a length of a third side of a triangle if the two other sides are 8 and 13. Okay. So assuming that these are the smallest sides that I have in a triangle, then the third side must be smaller than these two combined, right? That's what we learned in one of our lessons here. So if you take 8 plus 13, whatever your third side is, that third side must be smaller, right? So what you have must be bigger than the third side. So you have 8 plus 13, that is 21. That must be bigger than the third side. Okay. What if that's not the longest side? What if your missing side is not the longest, but it's one of the shorter sides? Then 8 plus that short side must be bigger than the biggest side in what you see here. So the bigger side will be 13 because that's a bigger number here. If you subtract 8, x is greater than 5. So what is the maximum? The maximum is 21. Your side cannot be bigger than 21. It has to be less than 21, right? X is less than 21. And the minimum is 5. X has to be bigger than 5. That missing side must be bigger than 5. Otherwise, you cannot make a triangle. Okay? All right, let me double check real quick. I believe that is it. We are done.